Now, let me take the first example again. Let's continue with our mole concept. Let's continue with solve problems on mole concept, or let's say mole concept examples. Let me take the first among the last examples again. I just wish to explain. Now, the question says, how many atoms are in 0.125 moles of oxygen? This is a very simple question. First thing you need to know is that anytime you hear oxygen in chemistry, they are referring to oxygen molecules. Anytime you hear oxygen, it means the same thing as what? Oxygen molecules. So here, first thing you need is 1 mole of oxygen molecule, 1 mole of oxygen molecule, or let's simply say 1 mole of oxygen contains 6.02 times 10 raised to the power 23 molecules of oxygen. So that means 0.125 moles of oxygen, 0.125 moles of oxygen molecules will contain 0.125 times 6.02 times 10 raised to the power 23 molecules of oxygen. And this gives you what? Let me check. 0.125 times 6.02. That gives us 0.7525 times 10 raised to the power 23 molecules of what? Of oxygen. Now, in this case, we are told to find the number of atoms, not the number of molecules. 1 molecule of oxygen. 1 molecule of oxygen has 2 atoms. So that means the number of atoms we have will be 2 times 0. What? Our number of atoms will be 2 times 0.7, 2 times 0.7525 times 10 raised to the power 23 atoms of oxygen. Since we know the number of molecules we have, this is the number of molecules that we have of oxygen. And we know that 1 molecule has 2 atoms. So all we need to do to get the number of atoms is to multiply our number of molecules by 2. That will give us the number of atoms. That's all. So you press your calculator. This will give you 50, then 150. So that will give you 150. That will give you 1.5050 times 10 raised to the power 23 atoms of what? Of oxygen. So that's how to calculate that. The second question says, let me explain the second example again too. The second example says, how many moles of hydrogen atoms? How many moles of hydrogen atoms are in 1.204 times 10 raised to the power 23 atoms of what? Of hydrogen. How many moles of hydrogen atoms are in 1.204 times 10 raised to the power 23 atoms of hydrogen? This is a simple question. Now, what we have here, this amount we have here is called N. N is what? 1.204 times 10 raised to the power 23. That's the number of atoms we have. Now, we are looking for the number of moles present in this number of atoms. So we write the Avogadro number. How many atoms are present in 1 mole of any substance? It's 6.02 times 10 raised to the power 23 atoms. So that means using the formula, N, oh, this is not clear enough. Let me stick to my orange. using the formula, using N is equal to N over Na. Using the formula, N is equal to N over Na. Number of moles is what? Number of moles is 1.204. The number of moles present will be 1.204 times 10 raised to the power 23 atoms divided by the number of atoms in 1 mole, 6.02 times 10 raised to the power 23 atoms. So you get what you need now. And that gives us what? That gives us, I think, 5. That gives us 5. 5 moles. That was what we got. You can redivide if I'm wrong here. But I think that's what we got when we used our calculator. Oh, sorry. This was 24, not 23. Let me correct this. This was 24. So that gave us 5. Let's go on now. Question 3. Question 3. I will go up to get my question. Excuse me. Okay, I need to go up to get my question. Question 3 says, how many moles are in 6.5 grams of zinc if the molar mass of zinc is 65? How many moles are in 6.5 grams of zinc if the molar mass of zinc is 65? Now, the reacting mass or quantity you have is 6.5 grams. The molar mass of zinc is 65 grams per mole. So, we are looking for number of mole. Remember the formula that says number of mole. What formula connects? Remember the formula that connects reacting mass, number of mole, and molar mass. That formula is number of moles is reacting mass over what? Molar mass. So the number of moles we have will be 6.5 grams over 6.5 grams per mole. So here, grams will cut gram, mole will go up, and you get what? You get 6.5 divided by 65. The number of moles present there is 0.1 moles. So take note of that too. Let's go to question 4. What do we get in question 4? Sorry, I'm going to be scrolling back up to get my question. Here in question 4, it says, how many grams of iron is in 2.025 moles of the metal if its molar mass is 56? How many grams of iron is in 2.025 moles? So we know the number of moles, 2.025 moles. Now, the molar mass of iron, 56. We are looking for the reacting mass. That's not difficult. What formula connects number of mole, molar mass, and what? And reacting mass. That N is equal to reacting mass over molar mass. So if you cross multiply here, what do you get? You get reacting mass is equal to number of mole times molar mass. So that brings us to the answer. Number of mole, reacting mass now will be equal to 0. The reacting mass will be number of mole, which is 2.025 times molar mass, 56. You press your calculator, you get your answer in what? In grams. Press your calculator, you get your answer in grams. So, that ends number 4. Question 5 now. Question 5 says, calculate the mass of sodium triazocarbonate 4 Na2CO3 present in 1.05 moles of the salt. Present in 1.05 moles of the salt. That's a simple question. We know the number of moles. Number of moles of the salt, 1.05 moles of what? Na2CO3. The question says Na is 23 relative atomic mass. These are in bracket. Carbon is 12. Oxygen has a relative atomic mass of 16. We want to find the mass. Calculate the mass in grams of this. So remember that number of moles is reacting mass over what? Molar mass. So we cross multiply. When you cross multiply, what do you get? You get mass is equal to reacting mass is number of mole times molar mass. Now, how do you get the molar mass of Na2CO3? Na2CO3 is the same thing as contains 2 sodium, 1 carbon, and 3 what? Oxygens. So that's 2 times 23 plus what? 12 plus what? 3 times 16. That's what? 46 plus 12 plus 48. 46 plus 12 plus 48, that's 60 plus 48, 106. That's the molar mass of sodium triisocarbonate 4. So the mass present, the reacting mass present in 1.05 is number of moles times what? Molar mass. Let me put that together very well. That's 1.05 times the reacting mass is 1.05 times 106, and that gives you your answer in grams. Now, let's be fast, quickly. You get your answer in grams and put it down yourself. Number 6, I'll go up to check the question. Question 6 says, calculate the number of ions in 0.0375 moles of tetraoxosulfate 6 ions. 0.0375 moles. Okay? 0.0375 moles. So I know the ion I'm dealing with, SO4 2 minus 0.0375 moles. N is 0.0375 moles. Okay, let me write this very well. SO4 2 minus. Says we should find the number of ions. Now, number of ions in this case is the number of particles. So we are looking for N here. So we know the Avogadro number. The Avogadro number says 1 mole of any substance or 1 mole of ions should contain 6.02 times 10 raised to the power 23 ions. That means number of ions using the formula. Remember, what formula connects Na, Avogadro number, N, number of particles, and small letter n, number of moles. This is Na, Avogadro number. This is number of particles in any quantity of a substance, and this is the number of moles present. What formula connects those three physical quantities? It is N is equal to N times Avogadro number. So number of particles is number of moles, 0.0375, times Avogadro number, which is 6.02 times 10 raised to the power 23. Press your calculator and you get the number of ions present. So you write that amount contains so number of ions of what? SO4 2 minus. You press your calculator to put your answer underneath that. Let's go to question 7. Question 7 says, Question 7 says, calculate the number of oxygen atoms in 3 moles of the element. 3 moles of the element. How many oxygen atoms are there? That's a simple question. First thing, 3 moles of the what? The element. That statement means the same thing as 3 moles of oxygen. And when we say 3 moles of oxygen, we mean the same thing as 3 moles of oxygen molecules. When we say 3 moles of oxygen, we mean 3 moles of what? Oxygen molecules. Let me try and see if I can write that better. Oxygen molecules. So 1 mole of oxygen molecule, 1 mole of oxygen molecule contains 6.02 times 10 raised power 23 molecules. That's what's present in 1 mole of oxygen molecules. So that means 3 moles of oxygen molecules will contain 3 times 1 times 6.02. You know that one can disappear. 3 times 1 times 6.02 times 10 raised to power 20 times 10 raised to power 23 molecules of what? Of oxygen. So this is the number of molecules of oxygen that you have. But one molecule has what? One molecule contains 2 atoms. 1 molecule contains what? 2 atoms of oxygen. 1 molecule of oxygen contains 2 atoms of oxygen. Therefore, number of atoms of oxygen will be 2 times the number of molecules you have. The number of molecules you have is 3 times 10 raised to power is 3 times 6.02 times 10 raised to power 23. So that means the number of atoms you will have will be 2 times 3 times 6.02 times 10 raised to power 23. It's as simple as that. Get the number of molecules, multiply by 2 to get the number of atoms, because 1 molecule has 2 atoms of oxygen. Oxygen is diatomic O2. So 1 molecule of it, which is written like this, contains 2 atoms, which are bonded, by 2 covalent bonds like that. So that gives you your answer. You have to do the math yourself. So this is the number of oxygen atoms we have. Let's go to question 8. On to question 8 now. Let's be fast. Question 8 says, calculate the mass of calcium atoms in 0.735 moles of the metal. Calculate the mass of calcium atoms in 0.735 moles of the metal. Let's go. 0.735 moles of the metal. So we have our number of moles. You are talking about calcium atoms here, Ca atoms. The number of moles we have is 0.735 moles of atoms. We want the mass. Molar mass of calcium is 40. So that's very easy. Are we looking for number of atoms or mass? Excuse me. Number 8, calculate the mass. Okay, we are looking for mass. That's very easy. We write that it is reacting mass that we don't have. That's what I've done here. We don't have reacting mass. So what formula connects number of mole, reacting mass, and what? Number of mole, reacting mass, and molar mass. What formula connects those 3? I gave you that formula at the beginning of the topic. Number of mole is reacting mass over what? Molar mass. So if you cross multiply, reacting mass will be equal to number of mole times what? Molar mass. So that helps us get our answer. Let me not waste space. I'll just put it on this side. So that means my reacting mass is what? 0.735 times 40. That will give you your answer in grams. Let me write this 7 properly. So 0.735 times 40 will get your mass in grams. Let's take 2 more. 10 is okay for this round. We'll take a few more in the next video. Let's just take 2 more quickly. Number 9 says, if 3 moles of a metal If 3 moles of a metal's atom weigh 72 grams, what is its molar mass? Molar mass is the mass of 1 mole. So 3 moles weigh 72 grams. That's very easy. 3 moles weigh 72 grams. So number of moles is 3. And the reacting mass is what? 72 grams. The total mass of those 3 moles is 72 grams. We want the molar mass of that metal. Very simple. Number of mole is reacting mass over molar mass. So if you cross multiply, number of mole times molar mass is what? Reacting mass. That gives you your molar mass as reacting mass over number of moles. So we get what we need. That's going to give us that's going to give a molar mass is 72 grams over 3 moles. So the molar mass of the metal is 24 grams per mole. The molar mass of the metal is what? 24 grams per mole. Take note of that question. Question 10 now. Let's take question 10. Question 10 now. Says, calculate the number of moles of sodium hydroxide in 500 cm cube of 0.125 moles per dm cube of its solution. So this one is about concentration and volume. Sorry about this. Just quickly. Okay, we are talking about sodium hydroxide. Now, the number of moles is unknown. We have the volume 500 cm cube. We also have concentration 0.125 moles per dm cube. We can write this as moles per dm cube like this, or moles per dm cube like that. So number of moles is concentration times volume, as we said before at the beginning. So number of moles will be 0.125 moles per dm cube. It can also be written like this, times volume 500 cm cube. The volume of the solution is 500 cm cube. And its concentration is 0.125 moles per dm cube. So using N is CV. This is the formula connecting the number of mole of the base, its concentration, and what? Its volume. And it's the same. That's the same for every other solution. So, but there's a particular note you must be careful with here. You cannot manipulate volume in cm cube with volume in dm cube. So you have to break this down. It will give you 0.125 moles per dm cube. To change 500 cm cube to dm cube, you divide by 1000. That gives you 500 over what? 500 over 1000 dm cube. You have converted it like that. So dm cube will cut dm cube, and you get your answer in what? Moles. Your answer will be 0.125 moles times 500 over 1000 is 0.5. So that's what? Number of moles of the base, which can also be written as number of moles of NaOH, is 0.0625 moles. That's your answer for that. Let me give you a few questions as your classwork. Let me give you a few questions as a class exercise. Just quickly. Number 1, I'll be reading the questions out, but I'll be writing only the parameters. Calculate the number of moles. Calculate the number of moles of calcium. Calculate the number of moles of calcium present in 80 grams of the solid if the molar mass of calcium is 40. Calculate the number of moles of calcium present in 80 grams of the solid if the number of moles if its molar mass is 40. Calculate the number of moles. Calculate the number of moles of hydrochloric acid present in 200 cm cube. Calculate the number of moles of hydrochloric acid present in 200 cm cube of 0.05 moles per dm cube of its solution. So you can write out the questions in words if you have the time and you like. Question 3. Question 3. What mass? Question 3. What mass of sodium hydroxide is present in 0.125 moles of the alkali? What mass of sodium hydroxide is present in 0.125 moles of the alkali? Sodium hydroxide has the formula NaOH. Given that the relative atomic mass of sodium is 23, the relative atomic mass of oxygen is 16, and the relative atomic mass of hydrogen is 1. So going forward, let's continue. Number 4. Number 4. How many atoms of hydrogen? How many atoms of hydrogen are present in 0.12 moles of hydrogen? How many atoms of hydrogen are present in 0.12 moles of hydrogen atoms? Given that the Avogadro number is 6.02 times 10 raised power 23. How many atoms of hydrogen are present in 0.12 moles of hydrogen atoms? If the Avogadro number is what? 6.02 times 10 raised power 23. Question 5. Let me now give you this twisted one. Not twisted, very simple too. How many hydrogen atoms are present in 0.5 moles of hydrogen molecules? How many hydrogen atoms are present in 0.5 moles of hydrogen molecules? Given that the Avogadro number is 6.02 times 10 raised power 23. Given that the Avogadro number is 6.02 times 10 raised power 23. So take those 5 as your exercise. I'll give you more when we treat more questions in the next video.